One of the so nowadays all JDs are including this Docker and Docker containerization. If you are a software engineer, you should know these concepts. So now these are basic, these are mandatory or skills for any engineer. If you are if you see any JD, right, so you can see Docker and Docker container. You don't need to have a deep understanding of this one, but at least basic knowledge. Okay, so I'm regularly taking for a full stack developer or ML engineer roles. Okay, in those roles, so I got the request of asking for Docker concepts as well. Okay, so that's why I included these concepts in our course. Okay, so let's see what is Docker and containerization, all this stuff. Okay, so let's see what is Docker. So Docker is basically the open source tool for containerization. Okay, so like that, so we can have other tools, but Docker is very popular, and most everybody, almost 95% of industry is using Docker. Okay, for containerization. It's open source as well. See, if you remember, I'm not sure about last 10 years or before 15 years, before Docker was there. Okay, the problem is, so initially developer will develop the application, and he will test it, and he will promote it to the QA. Okay, and QA will set up and will start testing, and maybe it's not working. Then QA raise a concern, and QA comes to developer say it worked on my machine. This scenario, did you remember this scenario anywhere? In initial days of my experience, I got this problem. Okay, so it works in my laptop or my desktop. If I given to the other member for testing, it won't work there. Okay, yeah, so that is a common scenario maybe 15 years back, not 10 years before Docker. That was a common problem. That is called so it works on my machine problem. Okay, it was very popular during that days. Okay, so Docker solves that problem. You cannot say it worked on my machine. Okay, if it works on your machine, it should work on all other machines. So Docker will give that feature to avoid it works on my machine problem. Okay, so Docker makes your app works no matter where you run it. So whether you can run in your local desktop or a laptop or in a cloud or testing machine or private server. Okay, if you develop an application with the Docker functionality, you no need to worry. If it is working in your machine, it just works in other places as well. Okay, and there are some concepts, Docker concepts, so you might have heard about those things, but let's see one by one. Okay, so I'll explain these things with examples. That's why I made this table. Let's see, Docker file. So the concept is a Docker file. Docker file is basically a text file with build instructions. Okay, if you see that build instructions, right, so you can take the recipe example. You can take a recipe, how to prepare a recipe, right? You have some book for recipes. Okay, in that maybe if you want to prepare let's take what rice, let's take simple way rice. If you take 1 glass of rice, you need to add 2 glass of water, right? These are the instructions. That's kind of a recipe. Okay, that is called Docker file. So basically text file with some instructions, how we are going to build the application. And so Docker image basically creating an image from Docker file. Okay, this is like cooked dish, like cooked this from by following recipe. Okay, so here we have a recipe. It's basically instructions. Basing on instructions, we prepared a food. That is this one. And Docker container. So Docker container is basically running instance of the image. We have an image and we are creating a instance of that. Okay, it's kind of, so dish is ready and we prepared a dish here and we are serving that dish to customers. Like let's say there are three tables, so dish is serving three different tables. Okay, and Docker hub is basically so placing all our Docker images. Okay, so there's a storing the images in a common place, that is a Docker hub. That we'll call as a recipe book or food delivery app. Let's say in the app, right, normally we'll see what are the items available, menu. In that menu you can see, let's say if you want to check more details, right, you can see, let's say in pizza case. So in pizza, right, you can see all top-ups of the pizza. So those are kind of menu items, right? Okay, so these are the four important commons, concepts. First three are very common. Docker Hub is so it's having a different ways. Okay, but first three are very common. Okay, so any questions here? I'll show all these things with the examples, so that you'll get this one. See, right? Any questions? Okay, let's go. Okay, so let's see the how we are going to containerize your application with the Docker. Okay, so basically containerization is the process of packaging an application. Okay, packaging of application and all its dependencies. Packaging application and all its dependencies into single container. If you see, right, if you buy a car for your kid, okay, car, any electronic vehicle for your kid, that pack contains so all the, like say a remote, okay, so remote control car and related cable related things and how to use instruction document, right? All these are combinedly so packed and we got the packet, right? That is called so basically containerization. Okay, so containerization is basically so including your application dependence, source code or any configuration related stuff, all were combinedly making one common file, that is called container. Okay, so if you make it like that, it runs on consistently across all environments, whether in so prod, QA, dev, all environments kind of thing. Okay, so it's a same like it runs everywhere. Okay, so let's see development phase. So initially we create a Docker file. Okay, it's kind of recipe. After creating a Docker file, we build the Docker file. Okay, so after building a Docker file, we got a Docker image. We see, right, the Docker image is read only. Once you create a Docker image, we cannot modify that. Okay, so after creating a Docker image, you run the Docker image to make a Docker container. So Docker container is read write. Let's take so Docker image, basically you created a dish, so dish is a read only, and so after serving, that is a kind of read write Docker container. So okay, so any doubts here? So build, run, these are commands, those are Docker commands. So normally this is the process. Okay, so you create a Docker file, you build it, you got the Docker image, you run it, you get the Docker container. That is a standard approach. So developer, yeah, uh, yeah. uh. No, this is a file actually. It's not a setup. Okay, so the Docker image contains all the dependencies. Uh, no. This is also a file. This is also a file. It contains. Okay, so your application source code, your dependencies, okay, configuration stuff, all these things is combinedly Docker image contains. Okay, so source code, let's say if you have a 10 files, we have those 10 files, and let's say if there are some dependencies, thus dependencies also it contains. Okay, so that's why if dependencies also already there in that, so so because all this within image, so if you have the dependencies, it can work anywhere, right? So that's the biggest advantage. Right, yeah, right, yeah, exactly, yeah. So I should use that word, plug and play, yeah. Okay. So that's the development phase. Basically, you created a Docker file, you build and create a Docker image, and you run in your local machine. Okay, you create an instance. So whereas end-to-end containerization, basically, so deploying end-to-end from development phase to production kind of thing. Okay, so let's see. We have a Docker file. You build it. You got a Docker image. Okay, so once you got a Docker image, you need to push that. So that we need to push to cloud. Okay, in the cloud we have a different hubs. Common thing is Docker hub, but most of the corporate companies will not use Docker hub. Okay, so if they use a cloud, each cloud is providing their own Docker containerization hub. So if you remember, or if you know about AWS, in AWS you have ECR. Okay, ECR, EKS. ECR is basically containerization store. Okay, containerization registry. Okay, ECR service for AWS. Docker Hub is a public one. Like that, all other clouds are also providing Docker Hub or AWS ECR. Okay, so normally corporate companies, they use their cloud specific thing instead of Docker Hub. So you can push that to either ECR or Docker Hub. So now, because we created a Docker image that is available for everybody to download and run. Okay, you're getting my point? The pushing is basically we are making sure it is available for everybody. So like a GitHub, in Git, right, you are pushing the code so that others can access it. Similarly, you created a Docker image and you are pushing that to the common place. From that common place, others who wants that image can download and use it. Okay, that's why we are pushing. After pushing, so people can pull Docker image, and after pulling the Docker image, they can run it so that you will get the container. Right? This is the actual end-to-end process. If you see, right, so you remember, so people are asking auto scaling, right? So if you have a more traffic, right, servers are automatically starts, servers are automatically down if the traffic is not slowly getting down, right? You got that scenario, right? You remember? Can you answer, guys? During Black Friday or weekends, traffic is more. Whenever traffic is increasing, automatically servers starts running, right? This is all because of this containerization. So what it will do basically, so I'll show. See, you are running one container. If you want, you can start one more container. So like that. And see, if traffic is increasing, you can start one more container. This is how. So container is basically your application server, your application only. So you just run that one, it will start the server. This is how it works. So let's say if suddenly traffic is increasing, initially you have 100 users, suddenly it got 1000 users. Okay, so instead of set up manually everything, you just run the docker image run command, it start the server. So load will be distributed. This is the advantage of that. Okay, and this is one. So this is one system, or another like that. You can pull another user and do the same process, and you can do another user. You can do the same process. Okay, so this is how auto scaling works. Basically, spanning the servers using a Docker. Okay, any questions here? More servers, right? Yeah, that's the thing. Right, yeah, exactly. They'll start the servers because request is coming. So let's take, instead of that streaming kind of thing, let's say you take common Black Friday or Black Monday or something. So Black Friday. So in normal scenario, say server. Let's take this scenario. A server can handle. See, this is also one of the designing questions, system designing questions. So people will ask in interviews how we are going to handle scaling. Okay, so you can ask more. You can ask more questions to the interviewer, saying all the limitations. How much is the maximum traffic? What is the technology? All kind of thing. So let's assume everything. You need to make a point. Let's say here, assume initially. So our server handles 100 requests. Okay, that's the scenario. So initially 100 requests. So our server can handle 100 requests. So let's say suddenly the requests are increasing. So there are 200 requests are coming. So your server cannot handle it. Either it will crash or response will be slow. How you are going to handle it? So in this case, one server is handling 100 requests. So you can configure the point saying that 80% or 90%. If 90 requests are coming during this time, span another server. Okay, so now, so if 90 requests are coming, start new server, because there is a chance of increasing 90 to 100 or 100 to 120. So if the requests are 120, our current server will not handle, because the server limitation is only 100. So if 90 requests are processing, you start the second server. That is called auto scaling. So now we have two servers. So two servers, capacity is 200. So we need to save this at automatically. No, nothing will come automatically. So we need to configure. Okay, so here initially basing on the traffic. So the traffic is basically number of requests. In this case, server means normally request and response, right? Let's say API call is coming. We'll take a simple scenario like that. So our server 100 requests can handle. Okay, so now 120 is coming. So one server will not help. So we'll configure if 90% of the traffic is consuming or coming. So increase the second server, launch the new server. Okay, so now we have two servers. 90 will be distributed to 45. So now it can handle, right? So again, so let's say there are 180, 90. So 90%. Let's say there are 180 requests are coming. Okay, there are 200 requests. So there is a chance of more than 200 requests so will come, because already 200 are there. So 200, two servers may not be enough. Now increase one more server. So that becomes 3 servers. 3 servers, 200 are distributed between 3 servers. Okay, so this is the auto scaling. This thing we need to configure in our infrastructure. Okay, so that launching, right? That launching normally, so if you see Kony, we need to configure, right? Everything we need to install, all the stuff. Uh, but if you follow the Docker container, so we have already Docker image here. You no need to do all the stuff again. You just run that command, Docker image run. It will start the again another server. Okay, so like that you can span. So in current our project, what we configured is, in development there is only one EC2 instance will span. Okay, in a stage we configure 10 instances. In production we configure 20 instances. Okay, and whenever so we are reading the messages from SQS. Whenever the messages are in SQS, it will span automatically. We configure like that. If SQS is empty, shut down servers. If SQS is having a message, span the servers. That is the condition. Lambda function we configured, and it will span the servers. Okay, so using Docker only. We use Docker for that. Okay, any questions here? Everything is clear? Yeah, yeah. Yeah, that way. So we configured 80% of traffic, right? So see, 80% traffic means obviously it will shut down. So there is a configuration max and min. Okay, so let's say we have a 3 servers. We because initially 250 requests are coming, so 2 are not enough. We span 3 servers. So 3 servers are running. Now the traffic is reduced. Only 15 requests are coming. Okay, if 15 requests are coming, 3 servers are not required, right? 1 server is enough. Am I correct? So for that, what we will configure? So we configured for 90%. That's a maximum traffic. Minimum traffic also we will configure. Minimum is 15%. If the traffic is 15%, reduce the servers. Okay, but maintain minimum 1 server. That's the thing. Okay, we cannot shut down all the servers. Maintain at least 1 server. Okay, and remaining you shut down the other server. And the condition is at least 15% or 15 or 20 depending on the requirement. Okay, so that configuration and running this Docker file, that is the difference. If traffic is 90%, Docker run. Okay, if traffic is less than 15%, Docker stop or something like that, container stop container kind of thing. Okay, this is the approach normally scaling of application. Okay, so maybe for UI side, right? So UI side, Docker may not be we cannot use Docker normally, like mobile app. Let's take mobile app. Mobile app, normally people will not use Docker. Why? Because we are not going to create a multiple mobile applications, right? So we are giving, and each user is having its own their own mobile and download it, right? So that's why scaling is not a problem for front end side. But if you are using a web app, okay, there is a possibility because more people are trying to access web, right? So then there is a chance of application may go down. Okay, so Docker containerization, so you cannot use in every scenario. So whereas for mobile application, Docker container is not required because mobile app is specific to user. They can download in their own mobile app, so there is no scaling issue. Okay, each user are having its own mobile app. Okay, so this containerization normally comes in the backend side because servers will get more requests. So the request comes from mobile, web app, some other UI side, and people try to hack all the stuff. Okay, so those scenarios will have this auto scaling, all the stuff. Any questions here? Okay. Yeah, so anyway we are discussing about Docker containerization. So we need to compare because everywhere people will whenever you're talking about Docker containers, people will also talk about virtual machines. Okay, let's see what is a virtual machine and let's compare containerization. You guys are also using virtual machines, right? Yeah, so virtual machines and containers, let's see. Both are similar, but so both are kind of virtualization concepts. Both are same. Virtual machine is a virtualized computer. Okay, container is a virtual runtime environment for an application. Okay, that is the main difference. Virtualized computer, virtualized application. A computer can have multiple applications, right? So that's a kind of thing. Let's see this high level picture. So if you see virtual machines, right? So we have an operating system here. This is a hypervisor. Just ignore this. But the thing is that you need to compare this one. If you see virtual machine, right? Virtual machine is having a OS, separate OS, and libraries, all the stuff, applications. So each virtual machine is having its own operating system. That is the main difference. Whereas containerization, right, it's not having any operating system. It's only having libraries, dependencies. That is the key difference. Okay, so that's why. So virtual machine will, if you want a separate operating system, you should go to virtual machine. So this example is, let's say, if you guys are using MacBook, what is the system you are using, guys? Can you respond? Anand, Gauri, Shiva. MacBook, right? So let's say, so but Anand, you already sometimes you use Mac, right? uh, iOS. So we are having why I'm taking this scenario, we are using a MacBook. Let's say if you want to use Windows, you install Windows virtual machine, right? So I forgot that name, virtual Parallels. Parallels is a, no, yeah, VDA is one thing, but Parallels is virtual this thing for Mac. Okay, Windows operating system for Mac, like that. Like that. Virtual for Linux, these things also. Virtual box used to be the one. If you want to install Linux in your Windows machine, yeah, Ubuntu or Linux into in our this thing, you can use virtual machines. Okay, whereas for application thing, you need to use containers, I mean Docker containers. Okay, any questions here? Okay, yeah, see so let's see Docker file format. Okay, so it should be so it should be the file name should be exactly Docker file, no file extension. It should be see, capital D, all smaller letters, Docker file. Okay, it normally it's placed in the root directory. So first instruction normally almost 99% starts with the from, okay, which defines the base image. This is the sample, this one. Okay, it's kind of instruction recipe I told, right? So same thing. So I'll explain these things once after showing the demo. I'll see this one. Okay, so all these instructions I'll explain. So some of the Docker commands. So all these things. So let's go to the sample code and I'll see. So for this purpose, I created on sample application. This application basically FastAPI application. It's having only one API. Get API. Whenever you are running that application, you will get hello FastAPI from Docker. Okay. So let's see. First, let me run this one. How to run? Do you remember how to run? Okay, just let me show you this one how it works, and then I'll Okay, this is the sample code. Without Docker I am running it. Okay, this is the source code. Now let's see the corresponding Docker file. This is a Docker file. So Docker file is basically what, so the definition of Docker file is basically it contains all the source code, dependencies, all the stuff, right? So for that, first we need to specify the Python version from the Python version. So 3.11 I'm using this is a Python version. So when you are installing this Python, right, it automatically install the corresponding required operating system related stuff as well. Okay, so this is a base image, and after that we are creating a directory in the Docker image app. You can give any name here. So normally as app is a standard one. We are creating a app, and after that, see, we are copying a requirement.txt file. We are copying from our local source code to the Docker file, and after copying the requirement.txt, we are installing it. So this is just a no cache thing, but it's not required. If you remove this, if you remember, pip install -r requirements, this is what we did, right? See, after that we install the dependencies. After that we are copying source code. We have a source code, right? So here in the case main.py, we are copied it. So until this thing, everything is done. We copied requirements file, source code, dependencies, everything we have done, and we are specifying run the application on 8000. The port number we are specifying. So here it's no need to specify, but this is a readability purpose. Okay, after specifying that, what we are doing is a command for running, right? So the same thing, uvcon, what we did, uvcon main app, host name we are specifying, port number we are specifying. This is a simple Docker file. Any questions here? Okay, so now let's go to the commands. So here we have a Docker file. Next, the command is docker build for building. If you see the slides, initially we need to build, right? So we need to build the image from the Docker file. So let's build it. I'll start this one. See, you always prefer command line. It's always good to use command line. Okay, so let's see whether Docker is running or not. First thing is docker -- version. I'm not sure. Let's see. Yeah. So maybe let me show that then. Yeah. So that should be in the root folder. That's what I told you, right? So main is a file, and this is a Docker file I have written. This project is Docker demo. In the Docker demo, main file is the one actually our FastAPI source code. Okay, it is taking only one API. Yeah, that also will be copied, but we can use a docker ignore is there. But yeah, so that's the next level thing. So that's why I did not specify. The first we'll take a basics thing, then we'll have. Okay. Yeah, that also we can do. So basically Docker file is instructions. Okay, so instruction, see here, this is a command, pip install, right? So here you can use, right, I think run cp also, these things will work, commands will work here. Git clone, git clone, like that you can do, because these are yeah, that's also fine. But the thing is that it's not advisable, because if you are cloning from a public repo, right, there is a chance of other suspicious files also will come. That's why you should not, in Docker you should not use, because Docker image is going to execute in production. Okay, so that's why external links should not be used in Docker. Okay, it's a kind of running commands only here. These are instructions, right? We are giving the instructions. So do this, do this, do this. Okay, from is a command. The work directory is basically create a directory and go to the directory. Okay, copy is basically copying. It's running the command, copy. So all these things. This is not required actually, but it's good to know, specify. Okay, these are instructions. We are giving instructions. So do this, do this, do this. Okay, so like that you can clone from GitHub as well. Okay, so here we have within the project, so normally it should be in a root folder, docker, so main. Okay, so now, so you can check whether docker is available or not. So docker hyphen version, we got the docker. So now all the commands will mostly, so docker related commands, Unix related commands, all will work in docker also, but you just need to append a docker before that. Okay, let's say ls. Before that you can use a docker space ls. So normally it works, so but you try to do like that. Okay, so instead of ls there is a ps command. I'll explain that later. So now, so we have a docker. If you remember this flow, once we have a docker file, what we need to do? Where is that? Yeah, so after docker file you need to build it. While building you need to specify the name, build name. So that's what this command. So let's say docker build. If you want to specify the name, -t. Okay, we are specifying a tag actually, vertical tag, name of this build. Let's say docker demo. Let's say docker underscore demo 1. Okay, we are creating a build for this project. The project build name is docker underscore demo 1, and from where we will take the instructions. We need to take the instructions, right, to build this. That instructions from the current folder. Here because where is the docker file? That docker file path we need to specify here. The docker file path here, it is in a root folder. That's why we are giving a dot. Okay, let's see. See building. If you see instructions, building, here everything is see from instruction 1 of 5. There are total 5 instructions. One from docker library it is installing. Okay, and extracting all the downloading all the images, the size it is specifying. We are building a docker image for that for our application, and the OS type is default is desktop Linux. This is OS and Python. Yeah, any questions? Yeah, to see first one is taking more time because it needs to download basic OS and Python, that way too. And the next one is 2 of 5, 3 of 5 completed, working directory, copying, and now dependencies it is installing. See, it's kind of creating virtual environment and installing those dependencies. See, all the dependencies it is installing. So all the dependencies are available in the docker file, docker image, docker image. So we copied source code and everything is ready. Now, so docker image is created. How do we know that docker image is created? Yeah, we got it's completed without errors. Let's see. See, naming docker is this, docker demo 1. This is the name, right? Let's see. So to see docker list of images, command is docker images. See, so I did lot of things, so you just forget about that. But see docker demo 1 is the name. So latest one. This is the image ID 29 seconds ago. The size of that my application is 191 MB. Okay, so 181 MB because so normally that application should not be that much size, because I used virtual environment. There is a .p, so I'll tell that as well later. Okay, you got my point. So basically we created an image. Docker image with the Docker demo 1. See, I created a lot of images. These are all I did. Okay, and Postgres, this database I downloaded. Instead of installing Postgres, I just used Docker image. See, Postgres Docker image size is 240 MB. Right? Any questions here? We created a Docker image now. What is the next step? Huh? Yeah, so publish, we created a build. We need to test, right, whether it is working or not. We created a build, right? We created a build. We don't know whether it is working or not. We need to run it, right? We created, see, after building, we got a Docker image. Yeah, we need to run that. So let's see the command docker run. What is that? Docker demo 1. Let's see. It is running. Docker demo, it is running. Let's see whether we can access it or not. It is running, right? 8000 port. See, it's not coming. The thing is that, let's see, so the concept you should understand is Docker is running within a container, right? But we are trying to access outside the container. Am I correct? This is my machine, but the Docker is running within the container. So from within the container to my laptop, there is a external thing. So we need to map container port number and external port number. Okay, that mapping, so you can see here. Sorry guys. See, when you are running a Docker, right, if it is a standalone application, that is fine. But if you are trying to access a port number, you need to specify that port. 8000 is container port, and this 8000 is our system port. Okay, that's exposing to the public kind of thing. Like this, you need to specify. You guys are getting? So here, so when you are running it, okay, when you are running it, Docker run -p. D is basically daemon. It will go to the background application. That's why -d. -d is optional. Actually, -p is a port, and we are mapping and exposing container port to the public. Container port is 8000 and public port is also 8000. Instead of that, container port is 8000. You can give, instead of 8000, anything you can give. Okay. So here -p port number. So for now I am giving 8077 8000. Let's see this. Okay, so here the port is already running. 8077 is already running. Let's see. So let me take 17. See 8000 is container within the container application port is 8000 and outside is 8017. So I can access now this application with the port number of 8017. Okay, so this is the thing. So now this is, we are accessing image from the Docker container. Okay, you are getting? So this is how Docker building and running. Okay, so now let's see, there are some frequent commands we need to check. I'll explain those commands. So if you want to push the Docker image to the Docker hub, first we need to log in and you can push that image. Okay, push pull. Normally these things we will not do, because in the corporate or in companies, normally we will not do git the Docker push, Docker only pull mostly will do, or DevOps team will do that. But majorly what we will do is, these are the commands: Docker images, okay, to show the list of images in our system. Docker RMI, this for removing an image. So Docker PS, basically listing out running containers in your local system. Okay, and Docker logs, and you see, let's say there are multiple containers are running. If you want to see Docker logs, is the one. And if you want to connect to the Docker container, okay, Docker exec, I'll show that as well. All these things I'll show now. Let's go to Docker images. First let's see Docker images. So here we have a list of images, right? So it is already taking a lot of space. So instead of that, I want to delete 7.82 this AI chatbot. See, AI chatbot is taking a huge memory, 7.82 GB. I don't want that. So I can remove that by using Docker remove image, RMI. RM for remove, I for image, and you can specify that Docker image name. Either you can specify Docker image name or image ID, anything is fine. If I do this, okay, see, this is a very common problem. Okay, I normally I face almost very frequently. I'm trying to remove a image, but that is already using by some container. See, that container is using. Let's see. So now let's see how many containers are running. So you can see Docker -ps. Docker -ps will give all the running actively running containers. See, AI chatbot is running. Okay, so I'm trying to delete that, but it's actually running here. So what I need to do, I need to stop that. Okay, so for stopping that, this is a container, right? So Docker stop container, Docker container stop that ID. Okay, container ID. Let's see. It is started. It is taking time, but it is stopping. See, the port number here is a mapping 77, right? Earlier it was showing already running, because this is using that 77. That's why we got this one. So it stopped. Let's see again whether it is Docker PS. See, there are no running containers. Now we can remove that. Remove AI chatbot. See, it's still showing this. So because, so in Docker, right, even though if you killed it, so that may not completely stop the container. Okay, so that's why you need to check. You always should check with -a. Docker PS will give only actively running containers, but if you use -a, it will give, see, lot of things exited. These things, see, even though they stopped, they're still in the background. So to clear these kind of things, the command is Docker system prone. This will clear all these background demons. So I'm running, so it's asking, I'm saying yes, so it will stop all these things. See, all these things, deleting containers. By this thing you can permanently, it's a kind of recycle bin, you are clearing in recycle bin as well. Okay, so 2.16 GB reclaimed. So now if you see docker ps minus a, see there are no thing. Now I can delete that chatbot. Remove chatbot. Deleted. Chatbot is deleted. So now let's see docker images. So AI chatbot is not here, we deleted it. You are getting? Any questions here? Other system. Okay. See. No. See. A container cannot. Yeah, you can give, but multiple images, multiple application cannot run in a container. Each container is one application. Okay. So each application is one container. You can have multiple containers. So container 1 for application 1, container 2 for application 2, container 3 for application 3, like that. Or for same application, container 1 is for application 1, container 2 for application 2 or application 1, container 3 for application 1. That's the scaling. Okay, it's a kind of see I'll explain the simple way. You prepared rice, okay, and you are distributing the rice to 3 tables. Rice is there in table 1, rice is there to table 2, rice is there in table 3. All these tables are independent, they are not connected. Okay, if you want to clean the table 1, you can clean table 1 rice. Table 2 is still running, table 3 is still there, right? But in all the part, application is rice only, right? Okay, or if you want to clean all the tables, okay, that is a system, Docker system prune. Okay, let's say the time is ending time and there are no customers and tables are there with leftovers. Okay, so leftovers, nobody is using that, customers are not there. In that case, you can clean it out. So by running Docker system prune. Okay, that's the thing. So see, normally container should contain only one application, right? So if you go to the dining table, normally a single person, right, only friends or family all sits on a single table, right? Others normally will not prefer outsiders, all the stuff, right? Yeah, similarly, so one application, one container. Okay, so now let's say, let me run this Docker this one more time, and let's go inside the Docker container. So this is what I am running, right? So this is the thing. So daemon -d will basically, this will go to the background. This is also one of the very common scenario for debugging purpose. Okay, I started one container. It is taking time. Let's see. It is taking this much time. Okay. Sorry. I stopped, man. Sorry. Docker ps -a. 8 seconds ago. Okay. Now let's see Docker ps. See, one Docker container is running. This is the Docker container. We can go inside the Docker container and see what are the things available in that Docker container. Okay, so let's see. For that, Docker exec for execute, -it is for interactive. Okay, interactive, and after that you need to specify this Docker container ID. I am specifying that. Run as a bash. So basically we will go inside the Docker container. See, now we are within the Docker container. See, so here, see, this prompt got changed. Currently we are not in my local machine. I have a Docker running. I am into the Docker container. Okay, so here you can see present working directory app, because in Docker file we specified app, right? If you remember, Docker file, see, we created app folder. That's why we are in a app. And here let's see ls. See, we have a Docker file main.py requirement.txt underscore underscore pycache, and let's see minus a dot env. Okay, we copied everything from here. So that's why, see, dot env, this thing, everything copied. Okay, this is basically improvement of writing a Docker file. If you use a copy dot, it will copy all the files, right? So normally dot env, this one is not required for us. Guys, you are getting that point? Yeah. So when you are this is the way of writing Docker files. It's a brute force way. This is for learning purpose. So when you are really working on Docker files, there we need to be more careful while copying or doing all the stuff. Okay, so let's take another Docker file. Let's say another Docker image. Let's keep this one is like this. Okay, so here you can see the see the file, whatever the content we have, everything you can see here, logs, all the stuff we can see here. Okay, you guys are clear? I'm coming out of this Docker container. I'll create one more by modifying. Let's copy only what we required. We required only main.py. We only required main.py. Okay, so now we have a Docker file. Let's create another Docker file. How to create a Docker image? Docker image, Docker build -t demo, Docker demo 2 dot. Okay, I'm creating another Docker build. It is building one more. See, I want to show you the difference. Okay, now we have Docker images. Sorry, Docker images. See, Docker demo 2, demo 1. Demo 1, I copied all the files from my source directory, whereas demo 2, I only copied main.py. Okay. Okay. See, there is a size reduction. Right, 181 to 155 MB. Let's see now. Let me run this. How to run this one, guys? See, Docker, instead of Docker demo 1, I'm taking demo 2 and I'm changing the port number because port number 17 is already running. Let's see Docker. So it created. Now let's connect to the Docker exec -it. This is you no need to specify complete thing, but yeah. See, now I am here. If you see here, see main.py requirement, because requirement txt we already copied in the above tab. So this one here we copied, right? Here we copied only main.py, right? Let's say -a. See, there is no .v and v all the stuff, right? This is the difference. Let's take one more Docker ps. Now there are two running. Let's see Docker exec -t e98 dash. Oh, sorry, dash. See, ls -a. E98, both are same ITs, I think. Let me connect to 8f. See here, you can see the difference, right? ls -a, here it is In this container we have .vnv, docker file, all the stuff, whereas here ls minus a we have only main env requirement and anyway it will create this is the generated content. So when you are running python.py files you will get at this one, this generated one. So you have only 3, but whereas here we have .vnv docker file as well. Okay, this is how you need to debug. So this is for debugging purpose. Okay, so most of the very frequently used commands, docker commands, are docker ps, okay, docker exec, docker images, rmi, and this stuff. Any questions here? Okay. What? No, so traffic condition is different. That is a configuration step, not in Docker. So Docker is running the instance immediately, running the application immediately. Right, yeah. Configuration you will do separately. So for that, let's say this Docker is handling 1000 requests. Okay, so whenever requests coming, right, we have a proxy kind of thing. So there we know how many requests are coming. Okay, that's how. See, it's kind of like a restaurant. So people are outside in a queue, but kitchen doesn't know about that, right? Kitchen people, how many are there? Kitchen people doesn't know. Is that correct? But manager will go and will say there are many people. Okay, so call more chefs. Manager will tell that, right? Recipe is there. Recipe is there in the kitchen, but people are waiting on outside, and the recipe and people are waiting. There is no relation, but manager knows it. Okay, manager is the controller here. Manager knows it, and he'll say, so there are many people are waiting outside. Let's increase the chef size. Call more chefs. Okay, that is kind of configuration. So recipe is there. We are not saying in the recipe, right? Recipe is there, but so manager will say that, hey, call more chefs so that we'll prepare more dishes. Okay? Are you getting my point? Yeah. So that's how it works. Any more questions? Yeah, if not, maybe I'll stop here for today. Yeah. I'm stopping my recording as well.